So we're doing the last part of this chapter, which is a mixture of everything we've done so far, as I mentioned a minute ago. We have mixed numbers, you have fractions, complex fractions, and decimals all coming at you at the same time. This is not fun. Actually, it is fun. So I did number 8 last time. Let's try another one of these. Let's try number 6. Alright, so let's look at this one here. Let me see in this one. Well, first of all, this one doesn't have a mixed number like number 8 does, but it does have a complex fraction and a decimal. So what I'm going to do, I'm going to show you how to do this in two different ways. You choose the method that works for you best. I'll do that all the time because I think we've been trained since school that there's one way to do math, and that's the teacher's way only, but it's not true. There's always more than one way to do problems and solve problems, and I always try to show you or help you see a method that works best for your style of learning. Okay, so first of all, we're going to deal with the fraction part first, and to do that, one thing you heard me say before, that if I don't like something, I cover it up so you can do it in the real world. Like right here, right now, the first thing we'll work on is the 112 divided by 16. So coming down below, if I do that, it's going to be 1 over 12 divided by 1 over 6, that's the divided by sign, multiplied by 3.6. What I'm doing this side, I'll do decimals. I'll just make a note of that before I move forward. This is a decimal way of doing it. So we know that there's no division in fractions. To get away from that, we turn this one upside down and multiply, or take the reciprocal. So I have 1 over 12 multiplied by 6 over 1 times 3.6. That's going to give me nice numbers. It's going to give me 6 over 12 times 3.6. 6 over 12 can be reduced. Can be reduced to 1/2. 1 over 2 multiplied by 3.6. And we can do 1/2. I mean, for me, 1/2, I would just put in 0.5, but I'm going to show you the long way of doing it, just in case you get stuck and you're trying to do this. We can just take this piece right here. And we can go 2 divides into 1. And we say, well, it can't go into 1, so how about this? Put a decimal here. Remember we did division with decimals earlier? Decimal up here, put a 0 here. Now 2 divides into 10.5. So then down here, jumping down to this part here, we can rewrite that as, hope not making it more confusing. So 1/2 becomes 0.5, so it's 0.5 times 3.6. And then what we can do, as we said before, taking the decimals, put one on top of the other one. So 3.6 multiplied by 0.5, and multiply the same as we would always multiply. 6 5s are 30, we go 0 and we carry the 3. And 3 5s are 15, and 3 is 18. And there's 1 decimal place, 2 decimal places, so we're going to go over 1, 2, and the answer is 1.8. Everybody fine with that? That's using decimals. So the only part in here that's kind of tricky is this part right here, where we got to convert the fraction into a decimal. All right, let's check this out another way. I just like drawing straight lines because I can on this. I can never draw a straight line, ever. So, back to here. So we're using fractions this time. So fractions. The fraction method of doing this, I'm going to have 1 over 12. Just rereading it again. 1 over 12, starting out the same way, multiply 1 over 6 times 3.6. Turning it upside down, first two parts are exactly the same, so it's 1 over 12 times 6 over 1 times 3.6. And then we know we get 6 over 12, same as before, times 3.6. And this reduces down to 1/2. I'm going to reduce it because it makes the numbers easier to work with. The 3.6 becomes 36 over 10. Now, let's look at that more closely. Can we reduce 36 over 10? They're both even numbers, so they should be able to be reduced. So I have 1 over 2. Both even numbers, so definitely 2 can divide into both of them. So 36 divided by 2 gives me 18. And 10 divided by 2 gives me 5. Are we fine so far? Now multiplying fractions together, it's just 1 times the 18 and 2 times 5, which gives us 18 over 10. And if we were to divide that, remember we did the shortcut division involving powers of 10? We can just take a decimal from here and move it over. So it gives us 1.8. And you can see the answer is still the same. But we did it with fractions, not with decimals. So you can do any method you want, fractions with decimals. It doesn't really matter as long as you're comfortable with the process. That's all that counts. How do you feel about that? See another one, or you just put some more review? Very good. The reason why I wanted to look at the chapter review this time is because it gives a kind of overview of the whole chapter, and plus we throw in some word problems this time. Let's look at this word problem here. It says your heart pulses approximately 1.25 gallons of blood a minute through its chambers. How many gallons of blood are pushed through your heart in 8 hours? How do you think we're going to approach that one? There's a couple of big things that are standing out in my mind. First of all, you notice that it's going to be gallons per minute and 8 hours. And there's one thing I didn't mention in here is that 1 hour 60 minutes. So I'm going to set this up like a, remember we talked about units earlier in the chapter and dimensional analysis and things like that, how the units will cancel as we're going through a problem and solving problems. Well, I want to show you how you can actually solve a problem, how dimensional analysis can actually help you solve the problem, okay? We know that it's going to be 8 hours, so let's just have a look at the dimensional analysis part of it. So what I mean by dimensional analysis, again, we have 1.25 gallons, 1.25 gallons, and we have over here, I'm going to write this down as 1.25 gallons, 1.25 gallons in 1 minute. So, taking that, what we know over here, these are like our equivalent statements right here. How do we convert that into 8 hours? Well, let's just start like this. This is going to be 1.5 gallons, and it's going to be over 1 minute. We want our answer to be in hours. So we're going to do this times 60 in. Sorry, our answer would be in gallons, my bad. 60 mins in 1 hour. Noticing as we move forward, the min here will cancel with the min. See that? Min cancel with min, minutes and minutes are canceling. Then I'm going to take that number, multiply it by 8 hours. Now you'll notice the hours will cancel, and I'm left with the units that I want, which are gallons. And that's how you can use dimensional analysis. Even if you don't know how to solve the problem, you know it's 1.5 gallons per minute, you know it's 60 minutes in an hour, set it up so that the minutes will cancel, set it up so that the hours will cancel, and you're left with the unit that you need. So that's using dimensional analysis. Even if we had no idea how to solve the problem, we just solved it with dimensional analysis because we know how to follow the units. We end up with a gallon, and then we can use our calculator to do the dirty work if you want to. So in the calculator, we can put 1.25. Times 60 times 8, and we get 600 gallons of blood in 8 hours. You don't have to use dimensional analysis, but you do have to realize that there's 60 minutes in an hour, 1.25 gallons in every minute. You do have to determine how many in an hour, then multiply it by 8 to give you 8 hours. So you will have to do that, but I mean, whether you use dimensional analysis or not, you don't have to. I like doing it that way because it's a safety check, a double check to make sure that if all the units cancel out properly, then you know you're going on the right track. So we want our answer in gallons. This is how many gallons, and our answer is in gallons, and it makes sense. So we probably did the question right. Let's have a look at another one. Calculate how many tablets are needed to fill an order of 0.5 milligrams of medication with 0.25 milligram tablets. How many tablets do you need? So what's this question actually asking us to do? Anybody have any ideas? The hardest part of a word problem is figuring out what the word problem is actually asking you to do and then setting it up. The calculations usually not that bad, but it's just what they're asking and how to set it up. So the important pieces we have right here are, we have 0.25 milligram tablets, and we need to fill the order of 0.5 milligrams. So, do we add, subtract, multiply? What do you do? You can divide. That's what I would do. But let's use dimensional analysis as well to make sure we're doing it properly. So we have 0.5 milligrams. So right here, this tells us that we have 0.25 milligrams in one tablet. So over here, we have 0.5 milligrams. We're going to want milligrams to cancel out, which means this piece here is on the bottom. So what I'm doing looks like this: 1 tablet over 0.25. And if I were to multiply this in milligrams, if I were to multiply like just by using fractions, just to show you what's happening here, this will be over 1. So I'm going to have 0.5 times 1, which is going to be 0.5 milligrams times tablet over 0.25 milligrams. And you can see it is division. And the milligrams will cancel. And since we're left with tablets, we got a good idea we're doing it the right way. And if you want to use your calculator, you can, or you can just divide it by hand. 0.5, I'll use the calculator to save time. Divide it by 0.25, you already know the answer. The answer is 2 tablets. All good? Not too bad? All right. Alright, just for review again, we were to sum these up because I don't want you to confuse adding them, multiplying them, because one way we line the decimals up and one way we just count the decimal places. So you gotta make sure you keep that straight. So the sum of 1.7, 19, 0.25, and 0.8. So start off with 1.7. When I get these, I'm going to write them one above the other. So the decimal place is there. There's no decimal place in 19, so 19 is going to look like this. 0.9, and you want to put a decimal in there, you can. 0.25 is right here, so we have 0.25. Then we have 0.8. You notice how the decimal places are all lined up? and straight line down. Now we're going to add them straight up and down. So there's nothing to add to the 5, so the 5 stays the same. 5 is here. The 8 and 2 makes 10, and that's 17. So that's 7. I'm going to carry 1. 9 and 1 is 10, and 1 is 11. I'll put 1 down here. And carry 1, which makes this a 2. And put my decimal straight down. I have 21.75. That's adding the decimals up. We're fine with that. All right. I don't think I did one of this, which is why I picked it out just to show you. I'm not positive I did one of these. Oops. 24.02 divided by 0.2. We put it in the calculator, it's not that bad because it looks like this. So we'll go 24.02 divided by 0.02. We get what? 1,201. Really? Alright, so thinking about that, how does that come from here? Let's do it by hand. I'll show you the trick that's involved. So basically, let's start like this. We have 0.2 divided by 24. I'm doing this on purpose. Bring that over here. 24.02. Alright, so it looks really confusing first, but what I'm going to do, I'm going to change this a little bit. Take the decimal here, move it here. If I move the decimal there, this one moves over here. So it's going to look like this. I'm going to slide back here. And I'm going to have a decimal up here now. So my new solution, my new division is going to look like this. 2 divided into 2, 4, 0, decimal 2, and decimal will go up here. So my 2 goes into 2 once, and when it comes to 2 comes down here, and I subtract, and I get 0. 4 pops down. Next 2 goes up here. 2 times 2 is 4. I subtract that. 0 pops down. 2 doesn't go into 2. 2 doesn't go into 0. It goes in 0 times. And then the 2 drops down. Take down. And I have 2. And that was in once. And I have 2. Subtracting. I get 0. Double check the calculator. Oh, I divide by 0.2. No something wrong there. So we have 24.02 divided by 0.2. And that gives us 120.1, as you can see right here. So what I didn't show you earlier, I don't think, is this trick right here, where when we have a decimal place that we're using to divide into a number, don't try to do this because this is motion pain. Take that and divide it and turn it into a whole number. So don't try doing this. Take it, turn it into that, move the decimal place once, move the decimal place here once. And it doesn't matter if there's 3 decimal places, move it 3 times in both places. It'll still be fine. But don't try dividing the 0.2 into 24.02. It just can be a little more challenging. This number here, we have 978.735, round to the nearest hundredth. Hundredth would be where? Would I do this number? Would I go 980, or would I choose 978.74? Round to the nearest hundredth. Well, it didn't say 100. H is there. Well, that's because H is a problem for Newfoundlanders. We have a big issue with H's. Just saying. For example, when I was over there, when I was in school, we didn't say H. We said H. So it's a H thing, and then we have a habit of dropping the H's when they're supposed to be there and adding them on when they're not there. So I came to Nova Scotia, and for the first 10 years I was teaching. I got corrected every time I said H. So I've trained myself to say H for some reason now, so I just say that. But I still sometimes struggle with like the adding and taking it off. So in any case, because it's a T H is there, we're going to have to go to the nearest hundredth. So this is the correct answer over here. My daughter, who was born in Newfoundland, but moved over here to Nova Scotia when she was in grade 2, didn't have a lot of like, I guess, growing up in Newfoundland, so she doesn't have a strong Newfoundland accent. And only what she gets from her family, from us, and from visiting home. And she doesn't really wasn't aware about the H thing, right? So we were driving back to Newfoundland one time. We were taking across the ferry, and we were stopping into one of those urban stations for breakfast. We were wondering, no, be careful, watch the lady ask you for your breakfast. She's gonna say eggs, not eggs. So she sit down. She said, the lady comes to service, and she said, "Oh, love, do you want one egg or 2?" And my daughter just about lost it, right? She's like, "They really talk like that over here?" Yeah, they really talk that way. So it's kind of funny. It's a different language. Okay. Come back here. I'll try one more and see. Well, you guys pick one. How about number 11? Convert to a decimal. Convert to a fraction. How do we feel about that stuff? Okay, so we'll try one of those. This is the ones where we have to be aware of our place value. Remember? Because the one here, this is 0.125. The 1 is in the tenth place, and the 2 is in the hundredth place, and the 5 is in the thousandth place. Don't ask me to say specific. I can't say that word either. So in any case, so remember on the right-hand side of the decimal, there is no ones place. It's just tens, hundreds, and thousands. So if I were to write that as a fraction, so it's going to look like this. If I have 0.125, that's going to look like 125 over 1,000. So you can start out with, reducing this. You can reduce this in many ways. We can divide by 5 and top and bottom, or we can divide by more than that. But let's divide by 25 because there's 25 will divide evenly into both of those. 125 divided by 25 gives us 5. The bottom 1000 divided by 25 is 40, I think. Are we finished at this point? No, we're not. You can still reduce further. We have a 5 and a 0, and they both be divided by 5. So, reducing further, 5 into 5 goes once, and 5 will divide into 40 8 times. And if you forget that, don't forget to bring in your multiplication tables with you to the test on Friday. So, just checking this out, because we don't believe me, because how could 0.125 be 1 over 8? Let's check it out. So if I did this, and I said 1 divided by 8, that turns out to be 0.125. Ah, I hate math. Let's get it into a fraction. Let's do this one. Convert this fraction into a decimal. You really want me to do that? Honestly, there's no way. Oh, look at the time. You gotta go. So we took it and turned it into a fraction. We'll do it the long and hard way of using long division. We know we hate long division, but we have 50 divided into 13. Right? The most common mistake I see is people writing it backwards. 13 divided into 50. No, don't do that. So the bottom one goes into the top one. So we know that there's no 50 in 13. So what do we do? We have to use a decimal. Decimal here. Decimal here. And put a 0 here. Now can 50 divide into 130? And go under twice, which is 100. 3 times is too much, so go under twice. So 2 times 50 gives me 100. And subtracting, I get 3. And there's 0 here. And 50 will not divide into 30, so I'm going to put another 0 there. And down here, another 0. And 50 will go into 300. 6 times 6 and 0, 0. 6 5s are 30. And when I subtract, I get 0 remainder. So the answer is 0.26. And if I did my calculator just to double check, if I went 13, oops, divided by 50, 0.26. Let's do one final one right here. Convert this into a decimal. Oh, starting out with a mixed number. That means we got to change the mixed number into an improper fraction, and then into a decimal number. Remember how to change the mixed number into an improper fraction? Well, let's have a look. We have 3, 5 over 8. And remember, I'm the visual head person, so I use the visual method. If you're not visual, you can come up with your own method, but this one works nicely for me. I take the 8, multiply it by the 3, I get 24. And I add it to 5. So I basically just do a circle, starting with the 8, do a circle right around, multiply and add, and that gives me 29 over 8. So, turning that into a decimal, going about the long way, I have 8 dividing into 29. And 8 can't divide into 2, but it can go into 29. 4 8s are 34, 3 8s are 24, so 24 works. I'll put a 3 here. I have 24 here. And I'm going to subtract. And it gives me a 5. 8 can't divide into 5, so this is where a decimal comes into play. I put a decimal here, and I put a decimal above the line right there. Then I can drop a 0 here, and the 0 comes down to here. Now, 8 divides into 50. 6 8s are 48. This is where your multiplication tables really come in handy. If I subtract, I get 2. So I'm going to put another 0 in there. Another 0 here. 8 divided into 20. 3 8s are too much. So I'm going to have 2. Which gives us 16. 20 minus 16 gives us 4. And another 0. And 0 comes down. This 0, I'll just draw the line so you can see how to go. This 0 comes to here. This 0 comes straight down here. And can 8 divide into 40? Sure can. Excuse me. And 5 times excuse me, my voice is still not that great. 5 times 8 gives us 40. 40, subtracting, we get 0. So the answer is 3.625. And that's it. And let's just try our calculator just to see. If I had 29 divided by 8 gives us 3.625. Looks good.